Hello 108 students, Mr. McHugh here with you on page 3 of section 8.7. We're going to keep working on complex numbers. And good news, we're going to learn how to add and subtract them, but you've already done this. And I come up with a phrase here called combine like parts, CLP. And really, when I show you this, you're going to say it's nothing more than combining like terms. The letter I is an imaginary number, the letter I used to represent imaginary numbers of the square root of -1. We just treat it like any other variable when it comes to add, subtract, multiply, divide. The big thing we're going to always keep remembering is every time you happen to get an I squared, I'm going to put this, swap it, you're going to replace it with -1. That is the new material that you're going to learn, so just keep that in mind. And so what I mean by combine like parts, look at an example of example 4, for a add complex numbers. Okay, so here's the beauty. There's nothing new here. 2 plus 3i is a binomial plus the binomial 6 plus 4i. If I hadn't told you that I was especially designated to be imaginary numbers, you would turn around and say 2 plus 6 and write 8. And 3i plus 4i combine like terms, and you'd write 7i and you'd be done. Okay, so you really can just call these combine like terms if you want. I just said like parts only because complex numbers have got real part and the imaginary part. It's the only reason I came up with that. Sometimes example B, they'll put binomials, or remember, a complex number is a binomial with a real part and imaginary part. Hey, they could stack them vertically. You love it. Simply add up the real part, add up the imaginary part. Just put the don't forget, if you see a negative I, put a 1 in front of it. Add them all up, 1 plus 4i, and you're done. You gotta love it. Not too bad, actually. Okay, now subtracting, the big thing, just like when you subtracted binomials before, you got to watch the subtraction. When I did this, I did these two problems. A and B are essentially the same. I don't know why I stuck them on here. I should have done something different, but I'm going to show you two different techniques. You're still combining like terms, combining like parts. 6 minus 3 is what I did here. 6 minus 3 produces what? 3. 5i minus 2i is 5 minus 2 and produces 3i. Okay, that's one way you could do those problems. Nothing wrong with that. Another way, and I'll do it here in example B, is some students are comfortable with, and you've got the warning sign, the big warning is that subtraction. You have to deal with the subtraction sign. When you have the plus sign, you just take the terms, like terms, add them up or like parts, and you're on your way. It's no problem. You got to make sure you deal with that that subtraction correctly. Now, another way to do subtraction is convert it to addition. You could turn around and you could do pop up the 1 in front of the second binomial and say it's -1 times I, -1 times -6. So you would have, I'll put it down here, what's -1 times 8? -8. Negative times the -6 is a positive 6i. Okay, and another way some people do it is they see the subtraction, they convert it to addition, then they go ahead and switch the signs from assume positive to negative, assume negative to positive. You got 3 choices here. Pick which method you like the best, but the bottom line is you got to deal with that subtraction sign. Okay, with that said, then you're left with 7 minus 8, which give you -1, and then -3 plus 6 is what? 3, so you're left with -1 plus 3i is your answer. Okay, so again, not new techniques, just recognizing I happens to be imaginary number. Now when you're adding, subtracting, you notice you didn't see any I squareds pop up. However, when you are doing objective number 4, multiplying complex numbers, use the distributive property, or FOIL is the two main techniques here. What happens when you see example 6a and it says 4i times a quantity 2 plus 3i, aka a complex number? Use the distributive property. That's your trigger in your brain because of the parentheses, the coefficient term in front of here. You're distributing and multiplying. 4i times 2 produces what? 8i. 4i times 3i, and watch. 4 times 3 is 12. I times I is I squared. Okay, you wrote the answer. You're like, oh yeah. If this was not a special definition of imaginary numbers, you'd be done, except for what? What's I squared equal? You got it. -1. You've got, this is the new part. So you swap I squared with -1. So you left the imaginary world. You're in -1. You got -1 times 12. And that produces -12. Now watch the form. The form is the real number plus the imaginary number. So -12 comes first, and then the 8i is second. Okay, so my suggestion, and if you don't follow this form, my math lab's gonna mark you wrong. So it's always the real number plus the imaginary number, forming a complex number. Okay, I think we've done it here, class. We're cruising. Only one more page to go. We will finish 8.7 and say adios to chapter 8. So I will see you. We're going to use the FOIL technique here I'm looking at. So I will catch you for page 4. Okay, bye.